Hello boys and girls, so in this video we are going to have a discussions on the Prelab Experiment 3 Potentiometer. So we hope that at the end of this video, students will be able to explain the experiment to determine the internal resistance R of a dry cell by using potentiometer. So boys and girls, before we discuss the questions, in order to understand the experiments, you might read over the lab manual. You might go to page 56. So you might read through the experimentary potentiometer, the objective, the theory, the circuit that we are going to set up, the apparatus we are going to use, and also the procedure for this experiment. Besides you read over the lab manual, you might also watch the video for experiment 3 potentiometer that you can access at the Physics KMJ channel under playlist experiment SP025. So you might pause the video and read through the lab manual before we start our discussion on our pre-lab worksheet. Alright, I hope you have read over the lab manual. So now we are going to answer some questions in the pre-lab worksheet in order to understand about the experiment that we are going to perform next week. So if we refer back to the lab manual, figure 3.1 is the potentiometer that we are going to set up in the experiment, and we notice that we are going to use galvanometer in the experiment. So question 1, what is the function of the galvanometer? So galvanometer will be used for detecting and measuring small electric current. Question 2, explain the working principle of potentiometer. So in this experiment, we are going to use potentiometer. So we have to understand the working principle of a potentiometer. So basically, potentiometer consists of a primary circuit and a secondary circuit. Whereby the primary circuit, we have a driver cell which is connected to a long resistive wire A, B. So that one will form our primary circuit. I try to highlight it so you can see the difference. So this is the primary circuit of our potentiometer, and then the voltage that we want to measure, or the dry cell that we want to measure, one of the terminal we are going to connect to point A of the wire. Another terminal we are going to connect to a galvanometer and a jockey. The jockey will tap on different positions on the resistive wire AB. So this one will form the secondary circuit. So how potentiometer work? So we are going to tap the jockey at different position along the wire AB until the G shows 0 deflections. So until the G shows 0 deflections. So when the G reads 0, it will telling us that there is no current that flow through the secondary circuit. There is no current flow through the secondary circuit, so it means that the potential between point A and the terminal positive and the potential X with the terminal negative is the same, because we understood the current won't flow when there is no potential difference. So as G reads 0, it means that the voltage across the point A to X will equal to the value of EMX EX. So refer to the primary circuit, refer to this primary circuit, we find out that when constant current flow through the wire, and providing that the cross-sectional area of the wire is uniform, the voltage across any length of the wire is directly proportional to that length. So our voltage across the wire, any length of the wire, is proportional to the length. So from this concept, we can determine the voltage across AX. Since voltage AX equal to EX, so in other words, we can determine the value of EX. So this is the basic working principle for a potentiometer. Then question 3, state two use of potentiometer. So basically, potentiometer can be used to measure an unknown voltage of a dry cell, and we use it to measure an unknown internal resistance of a dry cell and to compare between two EMF. Question 4, what is the relation between resistance and the length of the wire? So if we recall the concept we learned in lectures, for resistance R of any wire or conductor, R is equal to rho L over A. So we find out that resistance is directly proportional to the length L. So we refer to the equation, R is rho L over A. So R is proportional to the length. Question 5, state the SI unit and symbol for internal resistance and EMF. So for internal resistance, we denote it by small capital R. The SI unit for internal resistance is ohm. For EMF, we denote it by symbol epsilon. The SI unit for EMF is volt. Then we proceed to question 6. In a figure as shown in figure 1, if E1 is 2 volt and the internal resistance which can be neglected, so it means that E1 didn't have any internal resistance. The length of potentiometer wire AB is 100 cm. So the length of the potentiometer wire A to B is 100 cm. So when switch S is open, the balance length AX is 75. Balance length means the length when G reaches 0. So when the G reaches 0, the length AX is 75. And then when the switch S is closed, we find out that the length AX is 60 cm in order for the G to reach 0. So what is the internal resistance of E2? We want to find the internal resistance for E2. So in order to solve this question, we have to understand what actually we measure when our switch S is open and when our switch S is closed. Alright, so if we recall the concept we have in our lectures about the EMF and terminal voltage, when our switch S is open in an open circuit, we are going to read EMF of the battery or dry cell. But when our switch is on, the circuit is closed, then there will be current flow from the battery or the dry cell. At that time, we are going to read terminal voltage V, whereby the terminal voltage is the voltage that across the external resistor. So we are going to apply this concept in the question. So for this question, we will understood when switch S is open, as G reaches 0, actually the balance length, the voltage across the balance length AX will equal to the EMF E2 of the dry cell. So we can determine the value of E2. So applied voltage is proportional to the length. So we try to determine what is the value of voltage across A to X, whereby the length is 75. So if we refer to the primary circuit, the 2 volt is connected to across point A and point B. So for E1 2 volt, the length will be 100 cm. So if our balance length is 75 cm, when our switch is open, so what will be the voltage across this balance length? So we can apply V proportional to L. So E1 over VAX will be LAB over LAX. So 2 volt is given to 100 cm. So if 75 cm, how much is the voltage across that particular balance length? So we calculate, we get the voltage across point A to X will be 1.5 volt. So if VAX is 1.5 volts, since E2 equal to VAX, it means that the EMF E2 will be 1.5 volt. Okay, so we already determined the value of E2. Then we are going to use the condition of the switch S. When the switch S is closed, the new balance length to determine the terminal voltage. So when switch S is closed, we understood that as G reads 0, so now the voltage across the balance length 60 cm will be equal to the terminal voltage across the external battery. So VAX will equal to V terminal. So again, we are going to apply voltage proportional to L in order to get the voltage across the length AX. So E1 over VAX equal to LAB over LAX. So E1 is 2 volt. 2 volt is given to 100 cm. So when our balance length AX is 60 cm, how much is the voltage? So the voltage will be 1.2 volt. This, our terminal voltage will be equal to the VAX equal to 1.2 volt. So terminal voltage is the voltage across the external resistor. So the external resistor that connect to E2 is 5 ohm. So we can use terminal voltage equal to IR. So we can calculate the current that flow out from battery E2. So we get the current is 0.24 ampere. Then we can use E2 is I, R plus R. So to find the internal resistance. So we will get the internal resistance will be 1.25 ohm. So now we proceed to the experiment part, question 7. So if we refer to procedure 3, we need to determine L for at least 6 different values of R. So the manipulative variable will be the resistance R. The responding variable will be the balance length L. The constant variable throughout the experiment will be the internal resistance R of the dry cell we use. Question 8. Predict what happens if you change the polarity of dry cell. So if we change the polarity of dry cell, we will find out that the galvanometer will always deflect only in one direction and it will damage the galvanometer. Then question 9, why the jockey should not be dragged on the wire, instead the jockey should be pointed carefully. So in order to find the balance length whereby the galvanometer reads 0, we should tap the jockey at different position. We cannot slide or drag the jockey on the wire. This is to avoid we wear out the wire and the wire become deformed and also spoil the jockey. Okay, then proceed question 10. Given the circuit diagram below, discuss the reading of voltmeter when the switch is open and closed. So when the switch is open, there will be no current flow from the battery. So at that time, our voltmeter reading will be equal to the EMF of the dry cell. When our switch S is closed, we are going to have a complete circuit whereby the current can flow out from the EMF and flow through the external resistance. So at that time, the voltmeter reading will be equal to the terminal voltage of the circuit when the switch is closed. Then we go through the data analysis. So the internal resistance can be determined by using the following equations. In the theory, we have this equation, L0 over L equal to R in bracket 1 over R plus 1. The equation given will be a straight line graph that satisfies y equal to mx plus c. So we need to sketch an appropriate graph of L0 over L against 1 over R. So we might compare the equation with straight line equation y equal to mx plus c. So we find out that our y-axis should be L0 over L. Our x-axis should be 1 over R. So we are going to have an intercept that passing through positive 1. So if I sketch the graph, I should get a straight line graph whereby there will be a positive intercept around the value of 1. Question B, what does the gradient of the graph represent? So if we refer to the comparison just now, we will find out that our gradient actually will represent internal resistance R. So question C, in your opinion, how do we find the uncertainty of internal resistance delta R? So the internal uncertainty for internal resistance actually is equal to the uncertainties of the gradient. Question 12, list 3 precautions of the experiment. So first, we have to make sure all the wires is connected properly, secure and tight. Second precautions, before starting the experiment, we have to ensure that when jockey is put at point A and point B, the galvanometer needle will deflect in opposite directions. So this will indicate that we have correct connections and will get correct zero deflections in a galvanometer. That one is the second precautions. Third precautions, do not drag the jockey along the wire. So we shouldn't drag the jockey along the wire AB, but then we have to tap it at different position in order to get the reading of galvanometer show 0. Fourth, the EMF or the voltage of the accumulator should be more than the EMF of the unknown dry cell that we want to measure. If the EMF dry cell is greater than accumulator, then the zero deflection will can't occur in the galvanometer, then we will not able to take the reading. Last one, we might use a new dry cell for each of the experiment. So this is some of the precaution steps when we perform the experiment. So boys and girls, as a preparations before you enter the laboratory to perform the experiment, you can refer to the procedure and construct a data observation table for this experiment. Then we end our discussion about the Prelab for experiment 3. Then I shall see you in next video. Bye bye.